Hi. Quite often we get a question, can QuickSurface be used as an inspection package? I must say that QuickSurface is purely designed only for reverse engineering, which means you take the scan data and you build your CAD model on top of it. At the end, you can compare. But there are some features in QuickSurface that can help you to do this without the need to do any complex inspection reports. So let's see what I mean with this. I'll just create a new empty document and I will import a CAD file which is available and has been created by design. This is the CAD part and it has been created and you have scanned. What I can do now is just import this scan data into my QuickSurface. What you can see here is the CAD model and the scan data. In this case, in this scenario, we don't want to do any reverse engineering. We just want to compare the scan data versus the existing CAD model. How can we do this with the QuickSurface tools? The first approach which I take is using our Align interactive tool to place this mesh roughly in the orientation as it is in the CAD with some manual tools. This means I can pick the mesh, I can move it on the side, I can slightly rotate. The main idea here is that I would like to see the object almost in the same similar way, so I can pick the feature points. Don't need to be accurate at all, I can just press OK. So the next step would be to align this scan data to the existing CAD model. For this purpose we have something which is called Align Endpoints Alignment. How this works, you can pick points, you can see they're numbered from the scan data and the same point on the CAD model. You don't need to be precise, but the more the better it is. And you need to pick minimum 3 points which are nicely distributed in space. For example here, in this case 3 points theoretically are enough, but the more you pick the better. This point will be here. And also the other trick is you need to spread them into the space so the alignment gets better. And in this case I have 5 points which are enough, and I can just press preview. As you can see, using these points, the software roughly aligned the scan data to the CAD model. Let's see where we are. I can now, if you remember, I have the tool which is called Align Interactive. You can just do some fine-tuning. The main idea is you get the scan data as close as possible to your original CAD model. Once I have this, I need to use what is called the fine alignment. Fine alignment will take the whole scan part and will align it down to the CAD model. Let's try to do this. I pre-select the mesh, go to Align, Fine Align Reference Mesh. There is an option called Search Tolerance, which means that's why we did the first step to put this very close together. It will take a point from the scan data and we will look within this tolerance if it matches to the CAD model, and we'll try to optimize. I can just press OK, 1 millimeter in this case, and this is the global alignment of the scan data to the CAD model. Now you can press compare and you can see the color deviation of the whole object. What is bad about this approach, not bad, but just not enough, that sometimes the physical part is deformed, or you may have some other artifacts on the actual physical part, but you want to use specific areas which are most trustful, so for this alignment. How this can be handled in QuickSurface, I can just hide my reference CAD model, and using the edit mesh I can just select the areas which are most trustful. In this case I will just use the rectangle selection, make sure the select through is on, and we'll select this part here. Press close and show the CAD model again. I can press again Align, Fine Align the reference, and press OK. What is the difference in this case? The software uses only the selected points when it does the alignment, which means that now if I compare, this will be mostly green because this is what I wanted, but everything else would be quite apart. You can play even more. For example, I can just go and use my magic wand here. I can select the top. I can add probably these cylinders here to be used into the alignment, and then I can do again the new alignment. So you can do this several times by using this final line. At the end, you can get your scan data aligned to the CAD model in the right way. So your critical areas are, as you see, green, and then everything else is dark. What you get on the screen is the deviation. The green means you are within the tolerance you specified. Then you have 5 times this region, which is 0.5 millimeter, which is colored. And then everything else, which is out of this global tolerance, plus minus 0.5 millimeter, will be gray. It doesn't mean you cannot inspect. You can just place your mouse over this area and you can click to create a label. These labels can be useful later to put in your documentation. At any point I can just press clear labels and I can start again. Just put it here, put here, so you can get this colorful picture. This is a way far not an inspection package. There is no GD&T, no other complex reporting. What you can do with this object at the moment, you can go to Analysis and press a snapshot. The snapshot simply takes a picture of what you have on the screen, and you can just come to your Word document, you can paste it, you can put it anywhere. It's just a normal bitmap, and then here you can just type in your reports, information and stuff. There is no table or nominals to compare and stuff, but this is very basic for quick analyzing the shape that you may have. I hope this video was useful, and again, QuickSurface is only designed mainly for reverse engineering, but this feature set can help you in very basic cases to apply some color plot comparison.